In the freezing mud of the Ardennes in December 1944, a 68-ton German King Tiger sits silently abandoned on a narrow forest road. Its armored hull is completely unblemished by Allied fire. Just miles away, a swarm of dented American M4 Shermans relentlessly pushes forward, their engines whining but functioning. By every theoretical metric, the German machine was an indestructible apex predator, designed to dominate the battlefield. Yet, its elite crew wired their own tank with explosives and walked away into the snow. How does a technologically superior war machine defeat itself from the inside out without the enemy firing a single shot? The answer lies in a hidden, self-inflicted mechanical crisis that ultimately broke the back of the German armored forces. For decades, the narrative of the Second World War has been heavily romanticized by the memoirs of invincible panzer aces and tales of impenetrable armor. But behind that post-war mythology lay a much darker, far more brutal reality. It was a daily reality, defined by critically short engine lifespans, shattered final drives, and the infamous Maybach HL230 V12, a brilliant but devastatingly temperamental piece of machinery, forced to carry burdens it was never designed for. This is the story of what happens when the pursuit of over-engineered tactical perfection collides with the relentless, unglamorous mastery of American blue-collar, standardized logistics. It is a conflict fought not just with armor-piercing shells, but with spare parts, repair manuals, and wrenches. And it forces us to ask a profound question about the nature of modern industrial warfare. Did the relentless German obsession with absolute engineering supremacy actually guarantee their strategic defeat, while simple, interchangeable mass production quietly won the war? To understand how these two radically different philosophies took shape, you have to look at the brutal arithmetic of geography and resources that defined the mid-war years. By late 1942, the German High Command was staring down a demographic and industrial nightmare. They were trapped between the staggering, untouched manufacturing capacity of the United States in the West and the seemingly endless human and material reserves of the Soviet Union in the East. Albert Speer's Ministry of Armaments knew that Germany could never win a war of attrition. They simply did not have the steel, the oil, or the manpower to match the Allies tank for tank. The only logical strategic response was qualitative supremacy. A single German panzer had to be capable of destroying 3, 5, or even 10 enemy machines. This desperation for battlefield dominance was drastically accelerated by the shock of encountering the Soviet T-34 during Operation Barbarossa. In response, German engineers were ordered to design a new generation of heavily armored beasts. The result was a dramatic escalation in armored warfare. The Panther, originally envisioned as a 30-ton medium tank, rapidly ballooned into a 45-ton fortress. Soon after came the Tiger, tipping the scales at an astonishing 56 tons. But to move these massive steel leviathans across the battlefield, Germany needed an unprecedented power plant. They turned to Maybach Motorenbau, a company renowned for luxury automobile engines, which delivered the HL230 V12. On paper, this engine was an absolute marvel of mechanical engineering. Displacing 23 liters and pushing out nearly 700 horsepower, it featured a cast iron block and sophisticated dual carburetors. In a controlled testing environment, it was a masterpiece of precision. But there was a fatal foundational compromise. The HL230 was originally conceptualized to power a vehicle weighing roughly 30 tons. Hitler's relentless demands for ever thicker armor plate had pushed the Panther and Tiger far beyond their original design limits, effectively forcing a middleweight engine to carry a super heavyweight chassis. The power-to-weight ratio was immediately compromised, placing devastating torsional stress on the engine block, the cooling systems, and the delicate final drives. Compounding this engineering overreach was the deeply ingrained culture of German manufacturing. Companies like Henschel and Porsche operated with a bespoke, artisanal mindset. Tanks were handcrafted rather than mass-produced. Parts were individually machined and hand-fitted to specific vehicles by highly skilled craftsmen. It was a peacetime philosophy applied to the most destructive conflict in human history. Every vehicle was a technological masterpiece, but repairing one was an agonizingly complex process. To perform major transmission or engine work on a Tiger, for instance, mechanics often required a specialized heavy gantry crane just to lift the massive turret out of the way. 3,000 miles away, the United States faced a fundamentally different strategic reality. Detroit was not designing tanks merely to fight. They were designing tanks that had to be shipped across a hostile, submarine-infested ocean. American planners were restricted by the unyielding limits of maritime logistics. A tank could only be as heavy as the maximum load capacity of a standard Liberty ship's cargo crane, and it could only be as wide as the standard flatbed rail cars that would transport it from the factories to the eastern seaboard ports. This rigid logistical ceiling capped the weight of the American M4 Sherman at around 30 tons. Because of this, the American philosophy was not about creating an invincible apex predator. It was about ruthless, pragmatic standardization. The Sherman was designed as an industrial commodity, built to be operated by farm boys and factory workers with only a few weeks of basic military training. Knowing they faced potential supply chain disruptions, American designers built the Sherman to accept multiple different engines, ranging from the Wright radial aircraft engine to the Ford GAA V8, all engineered to fit into the exact same standardized engine bay. More importantly, they prioritized modularity. If an American engine failed, the maintenance manual didn't demand a fully equipped workshop and a master mechanic. A standard recovery vehicle could unbolt the rear hull, pull the entire engine block out, and drop a factory-fresh replacement in its place within a matter of hours. These two distinct worlds were operating on a high-speed collision course. On one side, a bespoke engineering culture had placed a highly stressed, overburdened mechanical heart inside their heavyweights, trusting that precision manufacturing would somehow defy the laws of physics and friction. On the other side, an ocean-spanning logistical empire was betting everything on simplicity, numbers, and the rapid replacement of standardized parts. The ideological stage was set, but the true vulnerability of the German gamble remained hidden in the blueprints. It was only when these heavy machines were finally rushed to the front lines for their first major operational test that this fatal flaw would be violently exposed. July 1943. The rolling steps of Kursk. Operation Citadel was intended to be the decisive, world-shaking debut of the Panzerkampfwagen 5 Panther. Two entire battalions, comprising exactly 200 factory-fresh machines, were offloaded from rail cars behind the front lines. Adolf Hitler had personally delayed the massive summer offensive for months, specifically to ensure these heavily armored new weapons would spearhead the assault. But as the columns began their initial road march toward the staging areas, the fundamental laws of physics violently asserted themselves. Before a single Soviet T-34 was even sighted in their optics, the heavy panzers began to self-destruct. Inside the cramped, tightly sealed engine bays, the massive Maybach V12 power plants were running dangerously hot. Operating under the constant, agonizing strain of moving 45 tons of steel, the engines overheated disastrously. Vibrations from the overburdened chassis caused poorly routed fuel lines to rupture. Highly flammable aviation-grade gasoline sprayed directly onto scorching exhaust manifolds. Suddenly, thick columns of black smoke began to rise across the staging grounds, not from enemy artillery strikes, but from spontaneous engine fires. Two Panthers burned completely to ashes, just rolling away from the railhead. For the tanks that managed to avoid the flames, the sheer weight of the vehicles attacked their own drivetrains. Dragging that much armor through the dirt required excruciating torque. The complex final drives, using straight-cut spur gears that were never originally engineered for a super heavyweight chassis, simply sheared apart. Drivers reported sickening metallic crunches as the gear teeth stripped away, instantly paralyzing the machines. The statistics from the frontline reports were catastrophic. By the second day of the offensive, mechanical failures had heavily decimated the ranks. By July 10th, merely 5 days into the greatest tank battle in human history, out of the original 200 Panthers, only 38 were classified as fully operational. The rest were immobilized, stranded, or burning. For the German High Command, the reality of Kursk was terrifying. This was not a minor teething problem. It was a fundamental structural revelation. Their highly anticipated technological masterpiece was functionally useless if it lacked the mechanical endurance to physically survive the short drive to the front line. A tank with impenetrable frontal armor and a lethal main gun is nothing more than a stationary steel coffin if its transmission shatters during a routine road march. The initial disaster at Kursk brutally exposed this vulnerability, but it was only the beginning of a systemic mechanical plague. As the war rapidly turned against them, keeping these fragile beasts running would evolve into an impossible mathematical nightmare. By the time the Allies punched through the dense hedgerows of Normandy and the Soviet Red Army launched the devastating Operation Bagration in the summer of 1944, the systemic mechanical plague infecting the German armored forces had evolved into an entirely unsustainable crisis of attrition. The fundamental mathematical reality of maintaining a fleet of super heavy tanks was catching up with the Third Reich, and the primary logistical records from the German heavy tank battalions, the Schwere Panzerabteilungen, paint a remarkably grim picture. The Maybach HL230 V12 engine, despite its theoretical brilliance and undeniable power on a test stand, was fundamentally tearing itself apart under the unforgiving conditions of sustained combat. Because it was forced to constantly haul between 45 and 68 tons of steel through deep mud, shattered urban rubble, and steep inclines, the engine was perpetually operating at maximum thermal and mechanical capacity. Logistical logs and maintenance diaries from 1944 reveal a stark, unarguable metric. Under actual frontline combat conditions, a heavy German tank often had an operational engine lifespan of less than 1,000 kilometers. Once a Panther or a Tiger hit that incredibly short mileage threshold, the engine didn't just require a simple tune-up or a routine oil change. It demanded a complete factory-level overhaul. Valves burned out, cast iron blocks warped under the intense, unmitigated heat of continuous high RPM operation, and the delicate gaskets succumbed to the violent torsional vibration of the overloaded chassis. But the catastrophic failure rate of the Maybach engine was only the first half of the nightmare for a German maintenance crew. The true horror of German engineering lay in what it physically required to actually fix these machines in the field. Consider the repair reality of a Tiger I or a Panther whose transmission had shattered or whose engine had seized. Because of the heavily compartmentalized and overlapping design of these bespoke armored vehicles, simple maintenance was a physical impossibility. The Tiger's massive transmission and final drives were located in the very front of the lower hull, while the Maybach engine was situated in the rear. If the transmission failed, a remarkably common occurrence given the immense strain placed on the straight-cut spur gears, a mechanic could not simply unbolt an access panel and lift the broken unit out. To extract the shattered transmission, the Tiger's enormous 11-ton turret often had to be completely lifted off the hull ring just to clear the necessary workspace. Doing this in a heavily equipped, pristine factory in Kassel was one thing. Doing it in a muddy, rain-soaked field in Eastern Europe or a bombed-out French village was a logistical nightmare. To accomplish this, German heavy maintenance companies relied on the Fries Strabelkran, a massive, specialized, 16-ton capacity, collapsible gantry crane. Setting up this towering piece of heavy lifting equipment required perfectly stable, level ground. an entire team of mechanics, and hours of uninterrupted assembly time. Once the crane was erected, it took days of painstaking, highly skilled labor to unbolt the heavy armor plates, lift the turret, extract the broken components, fit the new parts, and reassemble the vehicle. Furthermore, if a suspension torsion bar broke, mechanics had to remove up to half a dozen of the heavy, overlapping, interleaved road wheels, the infamous Schachtelaufwerk, just to access the single damaged component. In a static defensive war, where you control the territory and possess the luxury of time, this artisanal approach to tank maintenance is merely inefficient. But in 1944, the Wehrmacht was locked in a brutal, fast-paced fighting retreat on two distinct fronts. Finding dry, level ground, assembling a massive gantry crane, and spending 3 uninterrupted days unbolting armor was a luxury they simply no longer possessed. If a King Tiger snapped its final drive on a narrow forest dirt road with an Allied armored column advancing rapidly from a few miles away, that 68-ton masterpiece of German engineering was instantly reduced to a roadblock. Unable to tow it away without snapping the transmissions of 2 more heavy recovery half-tracks, the crew had absolutely no choice. They would drop thermite grenades down the open hatches, wire the Maybach engine with high explosives, and walk away on foot. This startling phenomenon did not go unnoticed by the enemy. When American and British forces first landed in Western Europe, Allied intelligence and frontline armored crews initially experienced a profound sense of panic at the sight of the heavy German armor. The sheer thickness of the Krupp face-hardened steel, combined with the devastating velocity of the German 88mm and long 75mm anti-tank guns, created a terrifying psychological barrier. An American M4 Sherman attempting to engage a Panther in a head-on duel was at a severe, often fatal, mathematical disadvantage. However, as the summer weeks bled into autumn, frontline American ordnance reports and combat logs began noting a strange, highly statistical pattern across the French countryside. Advancing Allied infantry and armored cavalry units were continually discovering dozens of Panthers and Tigers abandoned along the shoulders of rural roads. When ordnance intelligence officers inspected these hulks, they found something baffling. Many of these terrifying metal beasts were entirely unblemished. They had never been struck by an armor-piercing shell. Their armor was completely intact, yet their engine decks were left wide open, their tracks were thrown, and their interiors were heavily scorched by their own fleeing crews. As American intelligence debriefed captured German mechanics and analyzed the sheared gears and cracked engine blocks of the abandoned heavy panzers, a ruthless tactical realization swept through the Allied command structure. The Americans realized that they did not always have to penetrate the thick frontal armor to kill a Tiger. They just had to make the tank drive. The structural fragility of the German drivetrain became an exploitable weapon. If an American armored column encountered a heavily entrenched position of Panthers, they did not need to launch a suicidal frontal assault. They simply had to call in artillery, outmaneuver the flanks, force the German armor to displace, and make them retreat. Every single mile, a heavy German tank was forced to drive over rough terrain was a mile closer to a catastrophic mechanical failure. The American tactical perspective shifted fundamentally from a state of technological fear to a calculated exploitation of German mechanical fragility. They learned to weaponize friction, forcing the enemy's overburdened engines and fragile, straight-cut gears to do the killing for them. This strategic exploitation was only possible because the American military operated under a vastly different, highly pragmatic logistical philosophy. If the German armored force was a brittle sword that required a master blacksmith to sharpen, the American armored force was a relentless, self-healing machine. The United States Army Ordnance Department had designed their armored doctrine around the unglamorous reality that tanks break down constantly in combat. Therefore, they built their logistical counterpunch around the concept of ruthless, high-speed modularity. The American M4 Sherman was not designed to be an indestructible apex predator. It was designed as an industrial commodity whose primary user was not just the gunner, but the mechanic. When an American engine threw a rod, swallowed excessive dust, or took shrapnel through the cooling system, the maintenance manual did not demand a pristine factory floor or a massive gantry crane. Instead, the United States deployed specialized recovery vehicles right to the very edge of the front line. Using a highly standardized M31 or M32 tank recovery vehicle, which were essentially modified Sherman chassis fitted with a robust A-frame crane boom and a heavy-duty winch, an American ordnance team could execute a mechanical miracle directly in the mud. The rear hull of the Sherman was explicitly engineered to be quickly unbolted and swung open. In the freezing rain of a French field, with artillery echoing in the near distance, a trained American recovery crew could roll up to a dead Sherman, disconnect the primary fuel lines and throttle linkages, hook the M32's crane directly to the lifting eyes of the engine block, and physically rip the entire power plant out of the hull in one solid piece. Within a matter of hours, right there in the churned earth of the battlefield, they could crack open a wooden shipping crate, hoist a factory-fresh Ford GAAV8 or a Chrysler multi-bank engine, drop it perfectly into the standardized engine bay, bolt the rear armor back on, and send that exact same tank back into the fighting line before nightfall. The American tank was a weapon system built entirely around the concept of disposable, rapidly interchangeable modules. What took the German army days of agonizing, highly specialized labor in secure rear areas, the American ordnance crews were accomplishing in an afternoon in the absolute worst conditions imaginable. Yet, the ability to rip out and replace a shattered engine in the mud is entirely dependent on actually having a replacement engine to drop in. This exposes the fourth and perhaps most devastating disparity between the two warring industrial philosophies: the availability of spare parts. The American logistical supply chain was a marvel of oceanic scale. The massive fleets of Liberty ships crossing the Atlantic, coupled with the relentless trucking convoys of the Red Ball Express pushing across Europe, flooded the theater with interchangeable parts. An American armor division did not just travel with tanks, it traveled with a massive, highly organized inventory of standardized fan belts, carburetors, transmission housings, interleave suspension bogies, and fully assembled engine drop-ins. If a part broke, a replacement was already waiting in a supply depot just a few miles behind the front. Conversely, the German mechanics were trapped in a logistical nightmare of their own government's making. Albert Speer's Ministry of Armaments was obsessively focused on producing brand new, fully assembled tanks to satisfy Adolf Hitler's unrealistic production quotas and to maintain the illusion of strength for domestic propaganda. In this desperate pursuit of aggregate production numbers, the German industrial sector vastly neglected the manufacturing of essential spare parts. Factories were heavily incentivized to roll complete Panthers off the assembly line, while completely ignoring the frantic requisitions for replacement final drives, fresh track pins, and new Maybach engine blocks. As a direct result, highly trained mechanics in the Wehrmacht were rapidly reduced to scavengers. By the late autumn of 1944, maintenance logs reveal that German repair companies were completely starved of basic logistical support. To keep just 2 or 3 Panthers fully operational in a combat company, maintenance crews were forced into a desperate cycle of cannibalizing their own dying fleet. Under the cover of darkness, mechanics were stripping alternators, road wheels, perfectly good carburetors, and intact transmission gears from lightly damaged tanks, just to keep a small handful of heavy guns firing the next morning. They were bleeding their own armored strength dry from the inside out, voluntarily destroying repairable vehicles simply because the German industrial complex could not provide them with a single replacement gasket. The operational capability of the legendary Panzer divisions was not just being destroyed by Allied anti-tank fire. It was slowly suffocating through 1,000 severed fuel lines, shattered spur gears, and empty supply depots. The luxury of time and the strict requirement for heavy lifting equipment built into the German designs proved entirely incompatible with the brutal, fast-paced reality of a desperate fighting retreat. However, this systemic crisis was not solely a failure of metal, gears, and frontline logistics. The catastrophic mechanical plague tearing through the heavy tank battalions was merely a symptom of a much deeper rot. A hidden, catastrophic collapse on the German home front was about to drastically accelerate this mechanical failure, ensuring that even the tanks that managed to keep their engines running would soon face an even more invisible and entirely inescapable enemy. This mechanical vulnerability was systematically accelerated by a hidden, fatal collapse in German industrial resources and manpower training. Throughout 1944, the Allied strategic bombing campaign methodically choked off the Third Reich's supply of high-octane aviation fuel and synthetic lubricants. This resource drought forced the Wehrmacht to run its high-compression Maybach HL230 engines on heavily degraded, low-octane gasoline. This inferior synthetic fuel burned unevenly, causing severe engine detonation, destroying spark plugs and rapidly accelerating the wear on pistons and valves. Simultaneously, the crushing losses of veteran Panzer crews on the Eastern Front created a severe deficit of institutional knowledge. The specialized training schools, once known for their meticulous, months-long technical instruction, were forced to compress their curriculum into just a few hasty weeks. To conserve precious fuel reserves, new recruits frequently practiced driving on wooden simulators or light training vehicles, rarely operating a live 68-ton heavyweight until they arrived at the front. When these complex, highly sensitive fighting machines were handed over to inexperienced conscripts, the results were catastrophic. The bespoke Maybach power plants demanded a delicate touch, careful temperature monitoring, and precise RPM management. Instead, panicked novice drivers, reacting to the terrifying pressure of frontline combat, routinely slam throttles and over-rev their engines. Without the instinctive mechanical empathy of seasoned veterans, rookies threw tracks on tight turns, roasted clutches in thick mud, and sheared their own fragile final drives through improper gear shifting. Minor driving errors instantly compounded into total vehicle losses. This volatile combination of overweight armor, fragile drivetrains, synthetic fuel, and rookie drivers was about to be pushed to its absolute breaking point. The Wehrmacht's dying mechanical heart was setting the stage for Adolf Hitler's final, desperate winter gamble in the West. On the morning of December 16, 1944, that winter gamble violently erupted. Operation Wacht am Rhein, the Battle of the Bulge, was designed around a single, unforgiving metric: speed. The strategic objective was to capture the port of Antwerp, a plan relying entirely on heavy panzer columns punching through American lines before reinforcements could react. But to achieve this rapid breakthrough, the armored spearhead was forced directly into the Ardennes. It was a geographic nightmare for super heavy armor. The offensive funneled thousands of vehicles onto narrow, twisting, snow-choked dirt roads cutting through dense forests and steep ravines. In this freezing, unforgiving terrain, the hidden mechanical crisis of the Wehrmacht reached its absolute climax. The brutal inclines and deep, icy mud demanded maximum torque just to keep the massive machines moving. Under the desperate pressure of a ticking operational clock, inexperienced drivers slammed their throttles, pushing degraded synthetic fuel through their overstressed Maybach engines. The result was a logistical massacre. Before they even engaged the bulk of the American armor, the German spearheads began to suffocate on their own mechanical complexity. On the steep, icy gradients, the fragile, straight-cut gears of the final drives violently snapped under the 68-ton strain of the King Tigers. Engines overheated and seized in the freezing cold. Because the forest roads were flanked by thick pines and deep ditches, a single shattered transmission on a leading Panther instantly paralyzed the entire column behind it. The offensive choked, creating massive, stationary traffic jams of pristine, heavily armored vehicles that could neither advance nor retreat. Meanwhile, just a few miles away, the American logistical machine was executing a ruthless, high-speed resurrection. Operating in the exact same freezing mud, United States Army Ordnance recovery teams worked around the clock under portable floodlights. When Shermans were knocked out, M32 recovery tractors relentlessly dragged the battered hulls out of the snow. American mechanics ripped out damaged engines and dropped in factory-fresh replacements overnight, continuously feeding the exact same tanks back into the meat grinder. While the German machine shattered, the American armored force aggressively regenerated its own combat power. The Great German Winter Offensive ultimately ground to a halt. It died not just against stubborn American resistance, but because the mechanical spine of the Panzer divisions simply snapped under its own weight. The grand assault was paralyzed by broken gear and empty fuel tanks, leading right back to a lonely, perfectly intact King Tiger, silently abandoned on a frozen dirt road. Returning to that abandoned King Tiger in the Ardennes, its silence is no longer a mystery, but a testament to a fundamentally flawed doctrine. The image of the 68-ton behemoth left completely intact on a rural forest road perfectly encapsulates the vulnerability of complex, over-engineered systems operating in chaotic, imperfect environments. The German reliance on the highly stressed Maybach HL230 created a fleet of spectacular but fragile weapons that demanded perfect logistical conditions to operate, conditions that simply do not exist in a global war of attrition. They built tactical masterpieces that were entirely severed from the realities of strategic supply, effectively ignoring the fundamental rule that a tank is only as lethal as the supply line tethering it to the factory. The post-war mythology of the indestructible apex predator crumbles when confronted with the brutal, practical reality of industrial warfare. In the unforgiving mud of the front lines, possessing the thickest, face-hardened armor or the most devastating 88mm gun was ultimately irrelevant if the machine couldn't physically reach the battlefield. The ability to quickly swap a broken engine, standardizing production to ensure an endless river of spare parts, proved far more lethal than any singular feat of bespoke engineering. The German war machine bet everything on creating the perfect sword, failing to realize that victory belonged to the army that brought the best hammer and an infinite supply of replacement handles. Ultimately, the Second World War was not won by the nation that engineered the finest individual tank, but by the nation that built the most relentless, unkillable machinery of supply and repair. The myth of the invincible Panzer is captivating, but industrial warfare proved that tactical perfection inevitably succumbs to standardized logistics. It demonstrated that true military strength lies not in a weapon's ability to avoid destruction, but in its relentless capacity to rise from the mud and strike again.